One of the reasons I love exponential growth functions so much is because they have so many business applications. In this particular situation, we're going to take the growth factor that we learned about, the model that we learned about in the previous video, and we're going to apply it to interest rates. Now, many of you learned about interest rates, and the only thing you learned was I equals PRT. This is what we call simple interest. And it's equal to the principal, which is the initial amount, think of that as like your y-intercept, times the rate, the interest rate, times time. Now, the problem with simple interest is simple interest only pays you once a period, and it only pays you the same amount of interest each time period. It does not actually roll over on top of itself. Whenever money interest is added into your balance to calculate the next set of interest, this is actually called compound interest. This is how interest really works in the real world. Very rarely do you get a situation in the real world where you have a simple interest formula or simple interest rate working for you or against you. So you can see here in this little box we have a new formula built off of the growth rate, but this time we've layered in n value, and that n value is going to show us how many times we're compounding per year. And what that means is how many times the interest is going to be added back into the balance to get a new recalculation. And so this is very important because if over the course of a year, if you put the interest back into the balance and it's recalculated, it's now recalculated on a higher amount, and so you'll earn more interest. That is much better than a simple interest formula. Now, we can simply compound an account in many different ways. We can compound it, once a year, so we could call that annually. We could compound it monthly, semi-annually. We could compound it continuously, actually, but that's a different formula. You can also compound it daily. Now, if we do daily, we're just going to assume a year to be 365 days. And so, basically, you can use this formula to figure out how much your money will grow to at various compounding rates. And so you can look here in sample problem number 4. We've given you a bank balance problem that we want you to figure out the balance of the account depending on how it is compounded, and so we can see the differences in the account value that way. So go ahead and try sample problem number 4. Okay, so for sample problem number 4, we'll start with the account balance and we'll do an annual account balance. And so our initial starting amount was $1,000. So we're going to be 1 plus the interest rate, which is going to be 0.08 in a decimal format. Compounded annually, that's 1 time per year, raised to n times t. So we're only going to do this for 1 year. And the n is also, the n is also going to be 1 because it's an annual compound. Now, you want to get in the habit of being able to put all of that information into your calculator in one entry line, and if you did, you'll see that our new balance is $1,080. Okay, so let's see how that changes whenever we do this quarterly. Now, quarterly, here, annually, our n was just a simple 1, but quarterly, our n is going to be 4 times per year. So we have 1,000, 1 plus 0.08, and now this time it's over 4, and then we're also multiplying 4 times our t there as well. If you put that in your calculator, you'll end up with $1,082.43. So a little bit more money doing it quarterly. So let's check the daily. So n, and remember we're going to do 365 for daily. And that gives us a final balance of $1,083.28. And so you can see here, by compounding more frequently, our balance increases a little bit more because we're putting the interest back onto our account balance more often. All right, we'll discuss this concept a lot more in class so that you get a better understanding of it.